Okay, welcome to the third lecture of this week on staking. And since we have set up the private testnet in the previous lecture, we would now basically be ready to test some smart contract that is based on staking and withdrawing or claiming rewards. So in this lecture, the goal is to actually have a look at a simple such kind of a smart contract and to understand how to work with these things. But for this to make sense, basically, let's first go back to the definition of the script context in the OpShin ledger API to see how we can work with the things in there related to staking and rewards. So as we've seen before, the script context has this purpose, the script purpose. So in previous weeks, we have worked with minting and spending. And for this week, we will focus on the rewarding and certifying types. So as I said before, rewarding is for transactions that claim rewards, staking rewards. And certifying is for transactions that are related to removing delegation from stake pools and unregistering staking credentials. This we will focus not so much on, but just good to be aware it exists. So if we look at this rewarding type, we see that it has like one field here, which is the staking credential. And this staking credential is kind of the staking part of the address that is here trying to claim its rewards. And then apart from the script purpose, the script context also has this important field called txinfo, which basically has all the relevant information about the transaction that we could somehow make use of within our smart contract. So previously, when we were working with the spending type of contract transactions, we were basically using this input and output fields to check that only certain inputs are allowed or certain outputs have to go to certain addresses and so on. Then when we got to the minting type of transaction, we were using this mint field, which gives kind of all the tokens that are minted as part of this transaction. And now there's these two additional fields, decert and withdrawal. So the decert is related to this certifying type, which we will not use directly here, but what will be important for us is this withdrawal field. And this basically gives the information of what withdrawal is happening, so to which staking credential and how much ADA. So that's why it's a dictionary. So one transaction could have multiple withdrawals. So that's why it's a dictionary, and kind of each key value pair corresponds to one withdrawal of this amount of ADA to this staking credential. Okay, so having seen this, we're basically ready to have a look at this kind of example script here called staking. So the idea of this validator is that, yeah, so it controls the stake credential, and it allows that you can sort of only withdraw rewards if at least half of the withdrawal amount is paid out to a certain address, and this address will be a parameter of the contract. Okay, so in normal case, in the non-smart contract controlled withdrawal, basically this address could claim all of the rewards. But here we have the smart contract validated version of the withdrawal, where we enforce this additional condition that half of the rewards go to this other address. Okay, and yeah, in case the purpose would be like a certifying action, we just allow anything because we don't want to make any restrictions for these actions. Okay, so here we have basically the validator. So this looks similar to before. So we saw that in the spending case, the arguments here would be a datum, a redeemer, and a script context. Then in the minting case, we didn't have a datum because there's no kind of UTXO that is being spent, which could be where the datum could be attached. And here it's similar. So the rewarding type of validator also shouldn't have any datum because there's nowhere the datum should somehow come from. So in this case, it's important to note that this first argument is not a datum, but it's a parameter. So this will be provided basically when we build the contract, and then the actual remaining arguments will be only the redeemer and the context, of course. Okay, and as usual, validators don't have any return type. It's just either it passes, which would indicate that the transaction can go through, or we throw some error, in which case it would fail. And then here we have two cases. So as we said, if the purpose is of this certifying type, we just allow anything, so we just let the thing pass in this case. And otherwise, if it's of the rewarding type, we basically want to somehow find out what is the amount of rewards that are claimed in this transaction. This is done in this first part. And then we want to find out what is the amount that the transaction actually pays to this address that is the parameter of the validator. And then the condition we want to enforce is that sort of at least half of the withdrawn amount is actually paid to this address, so which is stated in this condition here. Okay, so we have kind of two auxiliary like functions here. The first one for getting from the script context how much is withdrawn to this staking credential that we get from the rewarding purpose field. And then the second function, which looks at the script context and the outputs of the transaction and finds out how many loveless are paid to this address. So let's quickly first look at this first function here. So we provide the staking credential, and we provide this dictionary of withdrawals that comes from the TX info withdrawal field that we saw here. And so we have a dictionary. So basically we just do the lookup with the key of this credential, and this gives us the amount as the value of the dictionary. And we also check here that it's somehow non-negative, so that somehow this withdrawal actually exists, because we put the -1 here, and then we return this amount. And the other function is kind of similar to, I think, something we've seen before. So we simply look at the outputs, and we want to look at specifically the ones that go to this address. So basically we do this kind of expression here that loops over the outputs, and for the ones where the address is equal to the ones that kind of we're interested in here, we just do this lookup that checks kind of for the token with empty policy ID and empty token name, which is exactly ADA, how much of this is in this value belonging to this output. So what goes to this address basically. Okay, so this I hope gives kind of an overview of how this validator works. So we've seen how those fields related to staking, so this withdrawal field in the TX info, and also in the script purpose, under the rewarding type, the staking credential. So these two things, we've used them in the smart contract. And yeah, this basically gives us kind of the tools to check some basic conditions related to claiming rewards. So now that we have the script, of course, we want to test it on the private testnet that we have set up. And in the next lecture, we will see how to do that. So I will see you in the next lecture.